I'm a manager at a traffic control company here in Michigan, Give 'em a Break Safety, and we deal with road and utility work occurring in the roadway, emergency situations, all things that are already hazardous in nature, and we confront those dangers while also ensuring the safety of workers and the motorists and pedestrians involved. My job revolves around planning and implementing the temporary traffic control plans. These plans are necessary to ensure safe, effective movement in the work zones. According to the U.S. Department of Transportation, there were 891 fatalities that occurred in 2022 in work zones. Michigan Department of Transportation, or MDOT, tells us that in 2023 there were a staggering 8,017 work zone crashes, and there were 24 deaths. 24 people, and this includes construction and road workers, general public motorists, and pedestrians, all lost their lives due to increased danger in work zones. And this is where effective temporary traffic control is essential to the safety of everyone on the road, and it requires experience and proactive planning to be successful. Today we'll talk about something most folks never give a second thought to. What is involved in temporary traffic control planning, and why is it crucial to the safety of workers and the general public? And these plans lay the groundwork for balancing the hazards of roadside work while managing and maintaining traffic flow while construction activities are underway. The main goal in mind while developing and implementing TTC plans is safety first and foremost, and next, minimizing traffic delays. We want to keep traffic flowing as smoothly as possible while keeping everyone safe. Traffic control plans encompass a range of considerations. While no two work zones are alike, and tailoring plans to fit each project is necessary. We look at traffic volume and the type of roadway to develop a traffic control plan. So first we look at the layout of the work site. I use Google Maps a lot for this. We're checking for info such as how many lanes so we can determine if flaggers will be required, or perhaps a right lane closure on a freeway with 8 lanes. Is there an intersection that would need additional provisions? We look at things like lane width and speed limit to determine certain components of the TCP. We also need to ask the customer what kind of work they're performing, like if they're getting in manholes in the middle of the road or pouring concrete on a curb. Will they be needing to close sidewalks and need a pedestrian detour? Now that we've gathered all that information, we can look into the standard traffic control typicals for help with the correct equipment and placement. The U.S. Department of Transportation has created typicals for almost every traffic control situation you may encounter. We refer to those guidelines as the MUTCD, Manual on Uniform Traffic Control Devices. They are considered to be the minimum and basic requirements for safe TCPs. Each state has their own Department of Transportation that has their own set of rules and regulations that must be adhered to. Every state is different, and here in Michigan, our safety standards are a little more strict than others. As you can see by looking at the two examples of typicals here, Michigan's typical require that we have more signage than the MUTCD. And we must use the MDOT typicals and guidelines when we provide traffic control on MDOT roads such as M36. And while we're able to use the MUTCD on non-MDOT roads, we will generally stick with the MDOT typicals as they are considered to be safer, and the consistency and routine works best for efficiency. Now let's look at what the work zone is made up of. A temporary traffic control zone generally has 5 sections: the advanced warning area, transition area, buffer area, work area, and termination area. The advanced warning area, first in this section, it is used to alert drivers of the upcoming work zone and give them time to adjust their speed and position. Here you will find your roadwork ahead signs. The transition area is the section that separates the advanced warning area from the work area, and it's used to guide drivers into the proper lane. This will be when traffic begins to literally transition lanes. The buffer area is the section that separates the work area from adjacent traffic lanes. It provides extra protection to workers and creates a barrier between the work area and moving traffic. The buffer area should always be larger and higher speed areas such as the freeway. And the work area, as the name implies, is the section of the work zone where actual work is taking place. It's important to keep this clear of unnecessary personnel and vehicles. The termination area, the final section, is used to guide drivers back into regular traffic flow. So you'll look for your end roadwork sign here. Another look at the components of a traffic control plan and the very important tapers, which are the channelizing devices used to guide traffic through the zone or close lanes or to separate opposing traffic flows. Here you can see the two main types, the merging taper and the termination taper. The merging taper is used to merge 2 lanes of traffic together, found in the beginning And the termination or downstream taper is the area that lets drivers know they are returning to their regular lanes. Here is every different kind of taper, and we can go more into depth in this after the presentation if you have questions. Knowing how to space signs and cones is a major part of traffic control planning and implementing. We have guidelines from the MUTCD as well as MDOT that give us these charts that we can come up with our sign spacing, as well as our cone or drum spacing for channelization. And we also can find our buffer space and everything with these charts. We have formulas that we can also use for finding taper lengths. Another handy chart from MDOT. We use the chart. We can find the taper length for a 30-mile-per-hour zone if we know the lane width. It's important to note that most lanes are at least 11 foot wide and 12 foot is considered ideal. So our lane is going to be 12 foot today for this scenario. The chart tells us the taper length is 180 feet. But if we needed to use the formula, we should come to the same conclusion. Let's see. Length equals width times speed squared divided by 60. So 30 squared is 900. 900 times 12 is 10,800. Now divide that by 60 and we get 180. So yay, math! Okay, so how many cones is that? Well, taper is 180 feet at 30 miles per hour. 180 divided by 30 is 6, so there's 6 cones. Now that we have covered just the basics of how we develop and implement a traffic control plan, I think we can all see that effective temporary traffic control begins with a well thought out plan that aims to ensure the safety of everyone on the road. And we do strive to minimize the impact on road users and try to avoid impeding traffic flow as much as possible. And however, I know that traffic control may seem like an inconvenience when your commute is delayed, but it plays a crucial role in protecting our lives. And the next time you find yourself in a construction zone, take a moment to appreciate the effort that goes into keeping you and the workers safe. Feel free to ask me in what ways you can help to keep our road users safe too. And for now, please remember to slow down and give them a break. It could save a life.